Hi everyone. It's been a long week, eh? I'm a bit out of gas. I think some of you are as well. So I have to do inspiring today. I am Mostaque, founder of Schelling AI. Previously, I founded Stability AI, where we built open source AI models with about 300 million downloads, around about 10,000 A100, so about 15 times as much compute as NASA, 10th fastest in the world. Originally, we built this as a DAO of DAOs, as it were, but we were like, where's the intelligence in DAOs? And sometimes we have to question where's the intelligence in Web3, I think. A smart contract should probably get a bit smarter. I've been in the space for about 10 years and I've lost too much money over the years. Now I think we're all here at the roll-up day. We're looking at intelligent security dynamics. We're looking at cultural sharding of different L2s and things. Where does AI come to play in this, and what is the state of AI today? I'm not going to go too long, but I thought I'd share some interesting things about where we may go. This is the first slide that I think is fascinating. This is IQ of AI models. So the new OpenAI AI model 01 is at 120 on IQ. That's pretty smart, But it's still a bit like a PhD student that hasn't had its coffee in the morning. Like, it doesn't really remember much. ChatGPT, you have to start it each time. We'll fix that, because this does score at the same level as a PhD student or a top 500 IMO mathematician. You're like, that's a bit crazy when you think about it, and especially how much it costs. But then this gets even crazier when you think about it in context. This is the average IQ by country around the world. So, here we're talking about like all these complicated topics, T, ZK, optimistic sharding, everything. We have to remember that the users of the technology we're building, 98% of them think they're above average IQ, but half of them are below. And this is an infrastructure thing, 76% of all Web3 developers are outside of the West. And again, bad infrastructure, poor infrastructure. We're trying to build better infrastructure for everyone. But this becomes really fascinating when you think about where we're going from here. As we go from these models that can almost do automatic translation, a word becomes an image, Or you say, like, rewrite this as a rap by Kanye West. Actually, a bit of homework for everyone here. Google has a new piece of software called NotebookLM, notebooklm.com. You can upload the eigenlayer white paper, and it will generate a podcast 8 minutes long, so you can actually understand it. What is intersubjectivity? You all must try it. Try it with anything, because these white papers, they do my head, and I'm sure they do yours as well. And this gives you an example of the way that you can translate between different types of information with these models, because that's what they are, universal translators. Looking at Apple Intelligence on your smartphone, it's a 3 billion parameter, 3 gigabyte language model with various optimizations around it. All of Wikipedia is 26 gigabytes compressed. The way these models work is we take these gigantic supercomputers, and they're using gigawatts of electricity now, and we compress the principles of knowledge. We compress context. And again, this seems very similar to what we're doing with roll-ups. We're looking at culturally contextual blockchains. We're looking at these individualized things to have specialized outcomes like base, like others. And we'll come to why that's important in a second. But before that, what is the cost of running these AIs that hit 100 plus IQ? This is a chart of the cost of running GPT-4 inference at 50 words per second. Now, unless you're a super genius, you can typically read max 12 words per second, or listen to that. This is crazy. It's basically a straight line down. And when you think about it, again, let's take Apple Intelligence as an example on your smartphone. It's pretty good. Probably give it like 90 IQ or something like that. It needs 5 watts of electricity. The human brain needs 20. A H100 needs 1,000. And when you think about what's happening here, and these models are still full of junk, you're basically moving to the point where intelligence is almost free. And we haven't responded to that yet in the Web3 space or even our conventional space. And it's kind of crazy to think about, because every single one of the people here can have an intelligence of over 100 IQ working with them on the edge. And that completely dramatically changes the infrastructure. If you add more flops, and this was the big breakthrough of 01, whereby you can now serialize computing, in that you let it go away for a few hours, and there are code models like Devin that will build entire stacks of code where you go away for days, the performance improves. That becomes even more interesting, because then you can build coordinators that have higher levels of compute. This is what the current stack of a model looks like. A little bit complicated, eh? The core is the knowledge brick component. That's the pre-training. That's why you hear these giant supercomputers that we ran. So at Schelling, what we're doing is we're putting supercomputers in all nations, and we'll be building the world's best cancer models, education models, government models, the stuff you need for living, fully open source. And then we use all those flops to secure a currency of the future by intelligence. It might work, it might not work. But we know how to build big models. And again, we think that stuff should be open infrastructure upon which you can build. That core pre-training step of taking all this data, and we take generalized data and more specific. So you might take a generalized human knowledge and then specify it to medicine, and then medicine in Malaysia. That first bit takes up about 90 to 95% of the compute. And again, you need these big supercomputers. We'll shift from that maybe, maybe not, but right now you do. On the left-hand side is very interesting. Has anyone here built those avatars, where it like has your face and then you're in space and stuff? So that was the stable diffusion model that we built, And what happened is people built on the base model, pointing to the space inside, all these contexts, a Pixar one, or an astronaut one, or you can make yourself look like a sheep. I mean, why not? You do you. Again, the Apple Intelligence in your smartphone has these LoRa's, or these adapters on top of the base thing, that direct it to a specific context. So it's reliable on the outputs. So you have these task bricks. And on the right-hand side, you have these modular bricks, where models can now take any type of input. So with Google's Gemini model, you can upload 10 hours of videos, and then you can say, find the similarities between these videos. So we'll be able to solve lots of cold case murders and stuff. But you can also upload your entire code base and someone ripping on it, and it will suggest adjustments based on that at inference time. You can accept any type of input and have any type of output with the models where they are now. Now, why is this important? Why is this important, and how is it relevant to what we're doing here? If you think about the nature of rollups sharing security dynamically, what we haven't been able to do is move past that first level of intelligence because we're still at the smart contract stage. We're very deterministic. These models now, we can have determinism or stochasticism, whereby they can behave in very reliable ways, but having intelligence on the client side allows us to route more intelligently. Having intelligence on the chain itself allows us to route more intelligently. What does that mean? It means we can have finely refined security. The security for a microtransaction is nothing. The security for a large Bitcoin transaction is very large. And we can have intelligent identity-based routing across layers, across chains, across cultural contexts. This is true intelligent intersubjectivity, particularly when you standardize the base models. And the computational cost of this is orders of magnitude lower than we've seen before for these types of things. So, are we there yet? Not quite. But this is just something to bear in mind, that we'll move from intents to having agents that work on your behalf to do whatever. And again, remember, most of our users have that level of IQ because of circumstance. We'll have the ability to go cross-chain, to go cross-indication, and behave in a way that's principle-based as well, because that's how humans work. Sometimes you don't always have deterministic outputs and situations where you can behave in a smart contract way. You have to behave according to principle. This comes down to things like MEV attacks and others as well, whereby we can finally have layers of security at every layer, from the client side to the server side to the routing side. So I think, this is just a little bit of a flavor of where we're going. Everyone here should really have a deep dive into how these models actually work, and the fact that we've now managed to get hallucinations down to less than 1% from 40%. The fact that these models can now work on the edge. The fact that these models can now adapt to everyone. And think about, what does system design look like there compared to what we have today, because it's coming incredibly quickly. And it's going to be a lot of fun, because ultimately what crypto comes down to in Web3 is agency. And these models will enable us to regain our agency. And I think, again, that's why everyone's here, because you have specialized indications required, because you don't want everything to be on one single chain. I don't want my healthcare records, education, the important stuff to be there. I want it to be siloed in a way, but still interoperable. And I want control of that. And that's what these models and these infrastructures will need and require. So please go and use them. Again, you've got your homework, Notebook LM. Tell me how the podcast is and if you understand intersubjectivity. Thank you, everyone.